This talk summarizes some of the most basic features of data fusion that we require to fuse ground and space detection statistics under INDD. This talk is intended to be fun, tutorial, and to help our disparate space-based and ground-based domain experts among INDD speak a common language and to better understand what they must provide to the statistics team that performs data fusion. What we'd like to do now is consider the basic requirements to fuse output from such detectors to make system-wide decisions that will ultimately define what multimodal data fusion is for INDD. So the text as I speak will highlight that describes data fusion concepts. The bottom cartoon will highlight symbols that more efficiently represent data fusion. We will start with signal modality detectors. So to begin, signal modality detectors process data to compute their detection statistics that then compare against thresholds to then make binary decisions about the absence of a target source or the presence of a target source. A multimodality detection system is a bit more complex. In particular, a multimodality detection system samples two or more modalities. Such a system includes several sensors that sample the many multiple source signatures. These multiple sensors then make collective binary decisions. And this is what we mean by data fusion. Just as with physics-based modeling of multi-signature sources, we impose constraints on such systems that control either the system-wide false alarm rate of the detection system or its error rate, and I do not show the error rate here. I also show the system-wide detection rate at top. The false alarm constraints of the system and the configuration itself quantitatively couple the thresholds of the detectors that comprise the system, and then solving for the thresholds that maintain the false alarm rate and that maximize the detection system rate, optimizes the system-wide performance of these fused detectors. These concepts of data fusion can apply to various types of sensor configurations that process data in particular sequences and that share or do not share decisions. I now consider three network types. These three models show distinct network topologies. They each have their own false alarm and detection rates that define their overall system performance. In this particular case, what we'd like to do now is make a decision about which topology serves us best. Two particular monitoring scenarios that apply to INDD are the parallel system here and the serial system here. You have seen the serial system in the context of selecting an apple. We generally select the system that provides the best multi-modality performance, and for small networks, you can prove that this is the serial network.